The idea is to expand the environmental monitoring of organic pollutants to larger chemicals, heavier chemicals than the ones that are being monitored at the present time. There are several questions. These compounds have not been studied because they are challenging in terms of analysis, of chemical analysis. So one question that we are going to answer is we are going to develop analytical methodology to analyze this type of compounds. The second question is, once the methods are developed, are these compounds environmentally relevant? Okay. The third question is, what are the isomers of these compounds most toxic? Okay, there are toxicological studies showing that heavier molecular weight organic pollutants have higher toxicity than pollutants that are lighter in weight. To give you an idea, a crucial example is one compound, the name is dibenzo-AL-pyrene. This compound is about 10 times more toxic than benzo-A-pyrene. And benzo-A-pyrene is the most toxic PAH in the EPA list. There are two components. One is the analytical component, and the other one is the synthetic component. The analytical component will deal with the analysis of these chemicals. What we are going to do is we are going to use laser-induced fluorescence spectroscopy. We use a pulse laser, and the pulse laser excites the sample at a given wavelength, and these PAHs or any other organic pollutant that we are interested is going to emit radiation with a characteristic spectrum. And the lifetime of that emission is also characteristic to the compound. So we are going to have several parameters to characterize this compound. That is chemical analysis. The other component is a synthetic approach. Many of these compounds are not commercially available, and that limits their analysis. We are going to synthesize the ones that are environmentally relevant so we can analyze them and look for them in the environmental samples. So our hope is that when we developed the methodology in collaboration with other researchers of the Gulf of Mexico initiative, we can track them down in environmental samples and better understand their photodegradation properties, and if they are toxic, if they are relevant, and if we really need to worry about them. The second component is educational. Analytical chemistry has been dominated by chromatographic techniques. Chromatographic techniques are very powerful, but they are not the solution to all the problems. Introducing laser spectroscopy, we hope to educate a new generation of analytical chemistries that can learn chromatography, laser spectroscopy, and some chemometrics, which is the analysis of spectroscopic data.